type of mesh methods here. We'll use here a various type based on the geometry, how are to say based on the geometry, the solver, the software itself updates the element types. So based on that, what are the different options we have to use mesh for different or various locations? How do we require the mesh quantity or the quality, everything. So for this, if I consider as direct or default values, I can say the material has not been updated. You can see. So you can see that a hex mesh is automatically updated. I'll update the material for this geometry which we have created. Then moving further, you can see there is a mesh which is already generated with hexa. Now I don't want this mesh. I want to change the mesh type, which is automatic is there. I'll select the geometry. As you see that there is an automatic method. When I select this, the method is automatic here. You can change that method to tetrahedral. So I'll show you. So tetrahedral. So once you update it, your other quality or the mesh type will change or it shows as failing. So now you can see when you have an option to use hexa or the geometry is very simple, you're using hexa, as well as you can change that to tetrahedral. Okay, and again here there is an option, you go for linear or quadratic. Linear in the sense that is first order and quadratic is a second order. Okay, so I'll consider a second order as well as your element sizing. There are different approaches. Again, adaptive, it will adapt itself wherever the geometry is changed. Approximate and curvature, based on the geometrical or critical locations, the minimum or maximum size it will be considering. Okay, so on that basis your software will allot your mesh features and mesh size. So I'll show you. Now you can see that when the option has been changed to the approximation and curvature, so your element size will change. So even you consider uniform, because you have used a method which is patch confirming method. That means node to node will be considered for the geometry. So similar, if I change the tetrahedral to your hex dominant in the sense only hexa element will be more in your geometry. Okay, you can see that only hexahedral has been changed. Now again here uniform, I'll remove this and use a approximation and curvature method. So you can see again your element size is same because it is simple. There is no much change over the geometry, so that your element size is not changing. So again, if you go for this, there is other in the adaptive method. There is medium, coarse, and fine. So I'll use medium now. You can check what will be your element size. These are the defaulted by your software. Okay, you can see that when it comes to when it comes to your medium, it changes the element size as well as the patch of your thing is different. So you can take this as a fine element and even check that. Now fine in the sense it goes too finer, mesh will go too finer, so that number of elements will be increased and number of nodes will be increased, which gives your geometry more complex to solve, or more number of nodes are increased, not complex, more number of nodes are increased. As here you can change this only hex or all chord on the 2D phases. So if I change that, you can see that your surface will be smoother for chord elements. Yeah. Now, as you see that there is very much disturbance in your mesh. Okay, so if I change that options, you can clear the smooth flow. You can see that smooth flow and the maximum face value. Here the default value is 25. I want minimum somewhere as 10. Based on that, your other parameters also will be updated. Now again you check for 10 mm size, you can see the finer mesh, right? So this is a difference between each type. So now, once we checked for hex dominant, now I'll go with sweep method. What exactly this sweep method in the sense? One face, it will be meshed with 2D, that will be dragged up. You can see that. So if I change the size again to 20, okay. So next, for this is one is for your method of meshing. So next, I'll take the sizing method. When I increase the sizing for this geometry, the element size is default as 20. You can change that to 5 or 10. You can consider each type of that and solve it. Now you can see that 5 mm. The size of your element or each particular geometry you can decide and mesh it. Okay. So that is one. And next, contact sizing. If there are two different surfaces, as of this, it has only one. There is no contacts, so it will not be showing you. So it will be a kind of error itself for you. Okay, so I'll just delete this and I'll show in further any other problem where we have two number of geometries, so that you will be easily knowing that. Next is refinement. This is very important. Refinement. Any part you require a slight refinement or your area of interest is at that particular phase. Okay. So I'll consider this refinement as 1, or I'll increase this refinement to 2 level. Okay. And remesh this. Or I'll go back to sizing. I'll give the sizing as 15 so that you'll get what type of refinement it does. Clearly, you will see that refinement value. You see, the two level of this phase I've considered, and two rows of refinement has been done. One, two, and the third row it is transition taking place from fine mesh to coarse mesh. Yes, everyone got what this refinement is. Even this refinement can be an edge. Okay, so here I'll increase this to 5 or 3. Okay, so now I'll mesh this. You can see that. Sorry, I have not changed there. Okay, one face is there. I'll change this to edge and update that. Okay, one edge is there. I'll update now. You will see the edge on the all the four side. Okay, the refinement is considered. You can see clearly. If I take a point edge also, sometimes what happens, one surface or one curvature is very critical location, but we can't do for that critical location, we can't change the entire mesh. Okay, considering my a tooling, this is a tool, one edge is very important to us to know the transfer of load as well as a heat transfer from the cutting edge. Okay, so at that moment you can use this kind of refinements and do the mesh so that it will capture more load over the edge itself. Okay, or on the surface itself. So this is a refinement. So moving further, face mesh. If I consider this face, okay, and there is a face over this, I'll just update. You can see that. You can see it becomes an hex. The face is, sorry, the face is having a clear path of load. Even I can update that. Both the face. Okay, it is updated now. Now you can see it becomes an art area. Whereas difference on this surface and this surface, the load path will be very straight, whereas the load path is disturbed over this. Okay, so that is also one of a method we use as a face mesh. And this is one, the pinch. You select a master and a slave geometry into like what I can say, on the contact upper and lower, that is master slave and master surface and slave surface, it will take considering two, and it will make node matching elements on the both the faces. Yes, so I'll just show you if it comes here. I don't think it will come. Yeah, it requires two bodies. I'll show that. Okay, so this is one which is like similar on the both the face. The node count and element count will be the same. There will no change in element and node count. The mesh will be in such a way it will be refined. And one more is inflammation. So this is also one of the important point. If I take the surface or a bond for this entire geometry, okay, and I'll select a boundary over this, so that I'll consider this surface. Okay, what exactly this do? So I have considered this, and I have taken 5 layers with approximate growth rate of 1.2, or I'll consider maximum. So you can see that the number of 15 layers are there. Something is geometry invalid method. I'll consider this edge. Okay, it works on the face or edges of the point. Now if I update this, I don't think it is updated. No, it is not updated. See, you can see the cross mark. It is not updated for this. It is not coming. Typically, if there are 2 to 3 or any change in the geometries, it will come. I'll show that. Inflammations. If I remove this refinement, okay. Sorry. Now I have removed the refinement and I have added the inflammations. Just select the geometry. It is not coming for this. The boundary. I'll show in the other problem for this inflammation. This is also one of the method. It gives an area or the capture of the point. So I'll remove this. I'll remove all the methods and then I'll show you the inflammation, how it works. It doesn't work on few of the faces because it is face is already, it should take 2, right? So it will be there. So it will not work on the few faces, face meshing or other things. It will destroy the one method to other method. So now I have considered the geometry, the body, okay, and now the edge I'll consider the only end point of this or this, okay, and I'll give a maximum layer 5 and the growth rate as 1.2 as a default, or you can increase any kind. So just update that. Now you can see the 5 layer from that edge. Okay, there are fine mesh with the growth rate of each. If it is 1, so it goes 1.2. If it is 1.2, it goes 1.444. It goes 1.68. In that way, it will be increasing in the rate of 1.5 or like 1.2 rate. If I want to increase it, you can take it as 5 and try also. Okay. Now you can see there are very fine mesh over there into 1 to 1. Okay, so that is the reason it will show in this way. Now I'll even remove this and insert inflammation. These are the other is node to node, manually you need to do it, like a node need to be moved. So I'll just take this node. Okay, I want to move somewhere here. You can see that my node manually have moved this element node, or so which is error, or also node merge. Okay, so I'll take this node to node merge. There are no two geometries. Again, this works on the geometry itself. Okay, node merge in the sense one node to the other of a geometry, node to node merge need to be can be done manually. So these are the few methods which are used while